Hello, I'll be reviewing homework 3, question 1. Most of you have done pretty well, and it's pretty straightforward. Just you have to show that beta 0 is unique minimizer, so you just need to verify the first order condition and the second order condition. So I have just a few comments on your answers. First, this notation, I understand what it means, but this is not universally accepted. So this is, the left-hand side is a matrix, and it is 0. And you wanted to say strict positive definite, but we do not write this way, right? Because like also similarly in vector space, we do not use inequality in vector space. So inequality is not naturally generalized to multidimensional cases in like even in vector or matrix. So do not use this notation. This is wrong, right? Wrong. Like I'm like yeah. And here so nice job. I did not check anything. Also, wrong notation. And a few things to say here. First, Susmita tried to say I like sum of squared errors. I understand what it means, but usually sum of squared errors is used as a result of regression. As a result of regression, you get residuals, like kind of prediction errors, and you calculate squared sum of them, like sum of squared errors. So this is more like a sample counterpart of what we are doing here. So this is purely theoretical object because expectation is population expectation, which is available only when you have infinite number of observations. So in this case, it is not a perfect name for this function. So I called Q0 as the criterion function because we are going to minimize or maximize it. So this is the population criterion function, not the sum of squared errors. But I understand what Susmita meant here. So, and another thing here is first, like the notation is not appropriate here. Square, you cannot take square of a vector. So already you took transpose, which means x is a vector. We know x is a vector. So transpose and square cannot go side by side. And also, the inverse is multiplied after another term here. So this is wrong. Like, remember, in linear algebra, pre-multiply and post-multiply are different. In scalar, like a plus b equals b plus a, or a times b equals b times a. But in matrix, it's not true. So this is wrong. It's not a matter of notation, but it is wrong. Post-multiplication is totally different from pre-multiplication. So keep that in mind. And also this notation is not appropriate. You have to say strict positive definite. And here, dimension mismatching. So y is scalar and x is k by 1 vector, beta is k by 1 vector. So you want to take transpose either one of them, right? But after transposition, this becomes 1 by k, and this expectation is also 1 by k, because y is 1 by 1, x transpose is 1 by k, so the dimension does not match. You also, also here, same problem happens. So x prime is 1 by k, and x is k by 1. So usually what we want is like, okay, let me tell you the answer. We want 1 by k from beta transpose, 1 by k, k by 1, 1 by k, k by 1. That's what we want because we want to have a scalar in the end, right? So it should be either 1 by k, k by 1, 1 by k, k by 1, or k by 1, 1 by k, like that. So Anyhow, so here it should be 1 by k, and then the next thing should be k by 1 to match the dimension when you multiply vectors. So it should be k by 1, then it should not be transposed. And here x should be transposed because here you will have k by 1, and the next thing should be 1 by k. So transpose it, and then this is correct. So this part is not correct, and the error continues to exist here. Okay, and minor problem, the differentiation notation, like what we call delta or partial delta, should be also added here. Okay. Okay, overall, question 1 was pretty simple, easy, and all of you have done pretty good job.